This is on the innovation side, if you will, and as you know, we're never afraid to try new things, to reach out to certain fields of technology or whatnot. And but this is really related to the core of manufacturing electronics in general, but not necessarily PCB. We've noticed a tremendous progress in printed electronics, which is also known as conductive ink, as some of the users, when we asked them the question printed electronics, they weren't sure, but when we say conductive inks, oh yeah, I know that.
Yeah.
And so we noticed a tremendous progress in terms of materials, like from DuPont, just amazing. And it has been used in the last 30 years. Somehow it remained relevant. And we've noticed some companies also are creating some amazing products, and but without the right tools. And one of these companies is called Tech2Tech, and they use Altium Designer. And we just seen just these amazing products. Imagine, for example, the car seat switches that move, the switch forward, backward, and whatnot. A typical car manufacturer will have probably like 30 parts or so, and it takes time to assemble them. And they're mechanical, and they look, kind of bulky. So they changed that with an in-mold, structural conductive ink design, if you will, and it just looks so beautiful, so flush with the design. It takes like 30. I think it's only 30% of the weight. It takes 20%, only 20% of the time to assemble. It's much cheaper to manufacture, and we thought, wow, this gives designers some new options with really clear advantages to develop certain applications. So we worked on them to develop the MVP, the minimum viable product. We said, well, what are the pains that you're going through developing this kind of board? So they told us, and those who are familiar with this type of design, in the PCB you have layer 1, layer 2, 3, and between each layer there's always isolation, so you don't have this problem of track from layer 1 touching a track from layer 2. But for printed electronics, because it's a printing process, there is really no layers. It's a layerless concept, but you have to only cover the areas where the tracks overlap, but otherwise all the tracks are in the same layer. So we developed a tool within Altium Designer that allows the software to look for those areas where the overlap is and flag them as errors. And this happens right after you change the layer stack into printed electronics, and it's accessible in the layer stack. It's really simple to use, and it really opens a new options for designers to develop, like I said, certain applications. And it's cheaper, it takes less time to assemble, and cost less to manufacture. And there's some studies that are just like, wow, if I have the option to develop something with this, I would do it in the fly.